Okay, so now I'm going to explain to you how to find the formula for the cross product using a coordinate system. This also will finally give an explanation for the choice of the way in which I have written x, y, and z when drawing the three axes. Remember that there's a unit vector here, I, another unit vector j, and another unit vector k. Now I didn't erase this from last time because the point of the cross product is that it will be a vector which is perpendicular to two given vectors, right? And so the reason why we label x, y, and z in this particular order is that if you think of I as a vector pointing towards you and j as a vector pointing along the y-axis like this, then when we do I cross j, we get the z-axis. So the choice of the labels for the x, y, and z axis is so that you get that I cross j equals k. Again, this k is a vector perpendicular to I and j, and then you just check that when you do the cross product of two vectors which are perpendicular of unit norm, then the new vector also has unit norm. So that's why there's no need to rescale it. And then when you do j cross k, you get I. And then finally, when you do k cross I, you should try it, but you get j. In fact, one way to remember this is that, as you can see from this formula, it's somehow cyclic in the sense that you can put here I, j, and k, almost like as being on a circle. And so when you do I cross j, you get k. When you do j cross k, you get I, and when you do k cross I, you get j. So you see, that's one way to remember the conventions. And also useful to notice is that we have I cross I. Again, if a vector is parallel, something odd happens, which is that the cross product gives you 0, which is not usually what happens when you do other products. The same goes with j cross j, and k cross k gives you 0 as well. Okay? So with this in place, we can actually try to figure out the formula for the cross product in the same way in which we found the formula for the dot product many videos ago. So how do we find the formula? Let's say that your vector u is going to have it's going to be this one, and okay, I'm going to call the coordinates of this point x1, y1, z1. On the other hand, we have this other vector v, which is x2, y2, c2. Okay, and then u cross v what is u cross v going to be? It's going to be x1i plus y1j plus z1k cross x2i plus y2j plus c2k. And now we do exactly what I did before with the dot product, which is just distribute. So you do this one cross this one. Plus this one cross that one. Plus this one cross that one, I cross k, go to second row, and I guess you know where I'm going, y1j, y1 x2 j cross I plus y1 y2 j cross j plus y1 c2 j cross k. Now last one. C1 x2 k cross I plus z1 y2 k cross j plus c1 c2 k cross k. Okay, and here we finally start using the information from this board. Notice that you can do something quick, which is I cross I, j cross j, and k cross k each gives you 0 vector, so you can ignore this part. If you have seen this before, I'm trying to arrange the numbers. There were 9 numbers. I'm trying to arrange them into what you would think of as a 3x3 matrix, if you know what I mean by that, which will be useful soon. And then the others, you just complete with the table. So this gives you x1, y2, I cross j is k. Then you get x1, c2, I cross k. I cross k is not quite here. You have k cross I, but remember that you can reverse the order if you put a minus sign. So you put minus j instead. Then you put plus y1 x2 j cross I. J cross I again is not here, but if you reverse it, it will appear at the expense of flipping a sign. And then this is the same as plus y1 C2 j cross k. J cross k does appear C1 x2 k cross I equals j. Plus C1 y2 k cross j equals minus I, and the other one gives you 0. Okay? And this is a bit of a mess still. So what we should do is arrange things so that they have the same unit vectors attached to them. So we can put y1 c2 minus c1 y2 I. Then you can put here c1 x2 minus x1 c2 j plus the last one, which will be x1 y2 minus y1 x2 k. Okay, and so this is the formula for the cross product of u and v. And then you see this, and this looks like a big mess. So what I'll do, we'll suspend, maybe let me do one example, and then I'll say more about this. Okay, so let's do an example first. I don't expect you to remember the formula in this way, but for now I'll tell you a trick soon to deal with it. So, but let's say that u was again x1, y1, c1, and then it's 1, 3, negative 2, and v is x2, y2, c2, which is in order to make this easy, let's put this here, 0, 1, 7. So the formula for the cross product will just be u cross v will be multiplying I, you get y1, which is 3, times c2, which is 7, minus c1, which is negative 2, times y2, which is 1. That's multiplying I. Multiplying j, you get z1, which is negative 2, times x2, which is 0, minus x1, which is 1, times c2, which is 7. And multiplying k, you get x1, which is 1, y2, which is 1, minus y1, which is 3, and x2, which is 0. And so you end up with, so 3 times 7 is 21, plus this is a bracket, so 21 plus 2 becomes 23. 2 times 0 is 0. Minus 1 times 7, so you get negative 7. And you get 1. So that's a vector that you get from that cross product. Now the point is that you don't want to compute it this way because it is way too confusing. In fact, I haven't done the computation in this way in a long time. In order to tell you how the computation is supposed to go, we need to talk about matrices. So a little bit. So what I will do in the next video is explain to you what matrices are, but maybe as a preamble for that, let's just make a special case of this formula, which is, let's say that you were actually working, like, let's say that you were in space, but now your vectors happen to be aligned along the xy plane. So you have a vector u, which is x1, y1, but it's the third entry is 0 because it belongs to the xy plane, and you have another vector v, which is x2, y2, but the third entry is also 0 as well. So what's the cross product in this case? Well, again, if you do the formula of u cross v, cross b, you get y1 c2, but c2 is 0, so that goes away. c1 y2, but c1 is 0, so this one goes away, so you get 0i. Then you get what happens on j. Well, it's c1 x2, but again c1 goes away, and x1 z2 and c2 goes away, so you get 0j. And finally, you get something here, which is, you don't know what that is. You just get x1 y2 minus y1 x2k. Okay? So that means that for two vectors on the plane, what I'm trying to say is that the cross product of x1 y1 comma 0 cross x2 y2 comma 0 is really the vector 0 0 x1 y2 minus y1 x2. Okay, and this quantity you can think of as a what's known as the determinant of a 2x2 matrix whose entries are since everything is 0 on the third slot, you erase 0, and so you can make an array of size 2x2, and there's like a formula which is known as a determinant, which I will repeat in the next video, which tells you that the determinant, that you extract a number out of this array called a determinant, and that is computed by multiplying the diagonal elements, right, this one and this one, and then subtracting the answer. Okay, so I'll say more about the determinant next time and matrices, but the point is that you should think of each of the factors here as some sort of mini determinant. So we will do that reinterpretation again in a moment.